Hello class, this is the first tutorial for text mining class, and in this tutorial we will introduce how to use R to do the sentiment analysis. Basically, we want to classify the sentiment for a movie review, for a certain movie review. So let's first look at our data. Well, we're gonna use this movie 1 dataset. So basically, it has two variables, two features. This label column represents the sentiment label. So it can be, this movie review can be negative or positive. And the other feature is the review, which each review is a chunk of text. So it is totally different from what we used to do, what we used to use, like those different features with either like numeric features or categorical features. This time we're gonna like analyze those text, this chunk of text. So let's get started. So these are a few packages gonna use in this tutorial. The first one is TM. TM stands for the text mining. So TM package is used for text mining in R, and word cloud is to generate those very pretty word cloud. And RYCAP, you should be familiar with RYCAP package. It was used for so many different classification algorithms and also the evaluation methods. And the next one is Snowball C. Snowball C package is used for the word stemming. And Carrot is used for partitioning the dataset. And RMiner, well, we will use one evaluation matrix from RMiner package. And CurlLab is used for building the support vector machine classifier. And RPart is used for the classification and regression trees. Well, if you haven't installed these packages, please do. And I already installed them, so I just load them. So next, we're gonna import our movie dataset, movie review dataset. Well, you can use the file choose like we used to use before, or I can set my directory and directly import this movie dataset. And this header equals to true, so we have those header label and review header available, and strings as factors equals to false, which means well, those will be imported as characters instead of factors. Let's check the structure of our movie review dataset. So basically we have two variables. The first one is the review contents I just showed you before. The second one is label. Both of them are now character type, but we want the label to be factor with two levels, positive or negative. And let's summarize these two variables. So the label, so basically we have 2,000 reviews, and among these 2,000 we have 1,000 negative and 1,000 positive, which means we have a very balanced data set. And if we see the proportion of our label variable, we can see like each of them take up to 50% of the reviews. Well, next we want to partition our dataset into training and testing dataset. We will not do the tenfold or n-fold cross-validation yet. We will not only like randomly partition our dataset into training test 1 and test 2. Well, like we used to do it before, training dataset is 50% of our total dataset, and testing 1, testing 2 are like 25% each. So remember to set seed. So we will have this random result each time we run this code. And we will use this create data partition function, which is from the library caret. So let's run this one. And this create data partition function, if you still remember, will generate a random set of row index, and those row index will compose our training data set, and the rest row index that are not selected by this function will construct our testing data set. And we further partition our testing data set to 25% and 25%. So test 1 and test 2 both has like 25% of our data set. So after you partition your training and testing data set, you can check the results. So we will use this enroll, summary, and prop table functions to see the distributions and also the number of rows in both training and testing data set. So for training, we have 1,000 reviews, and for testing, each testing consists of 500 reviews. And because we randomly partition them, the distribution probability for negative and positive class are 50%. Well, next we'll start to analyze the text using TM library. Well, the main function we're gonna use is TM underscore map. But before we use that function, we need to first transform our review content into a corpus. Well, there are two approaches we're going to introduce here to do this step. The first one is use the vector source first. Well, the vector source will turn your reviews into a vector of text, and then you put a corpus function outside this vector source function. It will turn this vector to a corpus. So we only first turn all our review from training data set to a corpus named train corpus M, and it should still contains 1,000 reviews. Well, if you have any questions about the functions, you can always use this question mark and the function name to see their detailed explanations. The second approach to transform the review to a corpus is using this data frame source. But before using data frame source, you need to first turn this review into a matrix, and then turn it into a data frame, and then turn it into a corpus. So these two approaches serve the same purpose. Well, the next step is start to use this TM underscore map function. It is from the library TM. It is text mining library used in R. And let's first check our first review. Well, you can see well, the first step we're gonna do is to change all the letters into lowercase letters. But you can see we already have all lowercase text content, which means this to lower function here doesn't make any difference. But we're still gonna introduce it here, so you can use them later. So here you can see you have a \n. This is the sample for line change. So it means, well, you start a new line here. So we will use this TM underscore map. The first parameter is the training corpus you just created. And if you want to perform the lower cases function, you use to lower here in the second parameter. And well, step 1 here is another like newly created corpus that contains all lowercase characters, letters. Well, if you want to see the first review in this corpus, well, if you only use this single square bracket, let's check. Sorry, let's check this one. Well, you did not see the content of the review. It just gives you, okay, this is the corpus, and you have one document. If you want to look into the review content, you need to put double square brackets. So this is the review content. Similarly, if you only use one square bracket and put a range from review 2 to 3, it doesn't show you either. But if you use the inspect function, and inside this inspect function you put in the range of reviews, it will present you with both of the review contents. Well, lastly, if I embed a help function inside of the inspect function, well, I can see here, I set this parameter equals to 3. I can see the top 3 reviews from this corpus, step 1. So basically this to lower function change every character, every letter to lowercase. Well, the next step is remove the numerical values from the corpus. Well, we only want the important words as our features to do the sentiment prediction, sentiment classification. So we want to eliminate all the numbers. So here we will use this remove numbers function from TM map function. So this one is used as our second parameters. The first parameters is a corpus from the first step, so it is step 1. So now we will create a new corpus, step 2. Step 2 eliminated all the numbers. So let's see the first review. So basically it removes all the numbers. Well, the third step is remove stop words or some certain personalized words you created. So what are stop words? Stop words are some words that doesn't have a lot of meanings. For example, the propositions or the articles and so on and so forth. So we want to first eliminate those words which doesn't contribute much to the sentiment analysis. So we will now change the parameter to remove words. And what words do we want to remove? We include another parameter in this third place, stop words. Well, we want to eliminate those stop words from English. Well, the default value for this stop words is English. So if you put nothing inside this parentheses, it basically also remove English stop words. So let's run this removing stop words. And then we check the first review again. So you can see the first sentence now transformed to two teen couples go church party. So they eliminate the word to, this proposition. And well, you can also like specify your specific word you want to remove. For example, here, I want to remove this word to. So I just, instead of stop words, the third parameter is the word to. And let's see. Now the first sentence came to become teen couples go church party. Well, you can have a set, like a combination of words you want to remove from your corpus. So in the third parameter, I use the combine function and include 4 different words. So I want to remove these four words because this is movie. These are movie reviews. So movie, films appears in basically every review frequently. So I want to remove those unnecessary words. Also, you can compose a parameter include not only the stop word, but also the specific words you want to remove together into my stop words. So this my stop words is your personalized stop words list. And then you put it in the third parameter. It will remove all the words from this list. So now we do not have any words from this list. Well, the fourth step is to remove those punctuations. Well, I will change the second parameter to remove punctuation. Use the step 3C here. And let's check. Let's see the first review. So now all the punctuation such as the question mark, the period, and this comma are all removed. And the fifth step is to remove all the white spaces. So those \n we discussed before, they're still here. But we want to remove all these. So we will use this stripe white space function inside this TM map function. So let's run this. So you can see now, instead of sentences in the first review, now the first review become a list of words. Well, the above 5 steps, such as removing stop words, removing white spaces, removing like numbers, and change them all to lower cases, are we called the pre-processing in text mining. So why do we want to do this pre-processing? Because in this review sentiment analysis, we want to like predict the sentiment, positive or negative, for each review in our testing dataset. And the target variable is the label, while the predictors, the features we want to use, are backup words, which are the word frequency contained in each review. So that's why we want to transform those reviews into like a list of words. Well, the next step is called stem. So what is stem? In linguistic, stem is a part of a word. So here is a stem example. Now we have 3 words: beauty, beautifully, and beautiful. And the stem version, the stem for these three words is beauty. So why do we want like the words to convert it to their stem in our training data set? Because if, for example, we do not convert them to their stem, so beauty, beautiful, and beautifully stand for three words. Well, I know we know that they're describing something positive. So in the training data set, we maybe one review has beauty, another review have beautiful. But if we have the third word beautifully in a testing data set, based on these two words from training, we could not know that this beautifully is also positive. But if we all use this beauty, which is their stem, so basically this beauty appears three times, twice in the training and once in the testing. So in the testing, we can imply this beauty is also positive. So that's why we use their stems instead their originally words. So here is another example of stems. There are four sentences, and we compose a corpus based on these four sentences. Then I use this stem document function to convert every word in this corpus to their stem, to its stem. So let's check the second sentence. The original one is applied for our open associate position. Now it was converted to apply for our open associate posit. Well, so we want this stem document to work on the words from our review in the corpus. Well, this line of code is supposed to transform all the words to their stems. Unfortunately, if you're using a Mac Pro or Mac Air like I do, this line of our code doesn't make any changes to the words. But if you're using a Windows machine, well, it will probably work like I did. I tried it on my desktop and it successfully gave me the stems for all the word in our reviews. For example, here continue, it converts to this, and things, and audience, and really, and so on and so forth. Well, we will talk about the solution for this problem later. Well, next, this is the end of the pre-processing. We basically use this tm_map function from tm library and change the second parameter to remove numeric numbers, remove stop words, remove a lot of things. So now for each review, we have a list of standardized words. Well, we want to calculate the word frequency for each review. So we want to transform the corpus to a document term matrix. So what is this document term matrix? Well, imagine now, okay, we have in our training data set, we have 1,000 reviews, right? So this matrix will contain 1,000 rows. So each row stands for one review. Well, then this function will combine all the distinct words together. So for example, review 1 has 10 words, review 2 has another 10 words, but they have 5 duplicates. So in total, they have 15 words. So if we build this matrix based on these two reviews, we will have 15 distinct words, and these 15 distinct words will be 15 columns. Therefore, if we have, for example, 1,000 rows here, and in total we have distinct words, how many? For example, 30,000. Well, then we will have a really huge matrix with 1,000 rows and 30,000 30,000 columns. And I drew a table as an example. So for example, we have 7 reviews, and this 7 review contains 7 distinct words. So if word 1 appears twice in review 1, the cell here equals to 2. Well, if word 3 doesn't appear in the review 1, the frequency is 0. So basically, the values inside this document term matrix, are the frequencies for each word in the review. So hope I explain it clearly here. Well, there's another unfortunate. If you use Mac Pro or Mac Air, well, we haven't figured out why yet. Probably is the version of R or RStudio or Java, but it did work on a Windows machine. But it will throw out these errors here, so we could not transform this corpus into this matrix. Well, if you are using a Windows machine, or you can probably try this line of R code. But if this line of R code throws you this error, well, we figure out we can directly use this document term matrix function. So this string corpus M is the original corpus without any pre-processing, and we can add more parameters inside this document term matrix function to do the pre-processing. For example, here, if we set this remove numbers equals to true, remove punctuation equals true, so on and so forth, it basically serves the same purpose as the function tm underscore map. So if you use this line of R code, you do not need to do the pre-processing 6 steps I said before. You can do it here in one line of R code. And this one doesn't throw us with any errors. That's really lucky. Well, it may take a few seconds. Okay, so let's see the dimension. So basically it is so here, like 1,000 rows, more than 22,000 columns. So basically 1,000 reviews contains over 22,000 distinct words. Well, some words are randomly rare appear. For example, in 1,000 review, it only appear once or twice. So we will remove those sparse terms, only remain those frequent terms. And you can go check the remove sparse term here. So this is the second parameter is a threshold to eliminate those sparse terms. Let's check our dimension again after eliminate those sparse terms. So now we remain 20 words, frequent words here. So next, we want to display the most frequent 20 words from this 200 frequent words. So we know that each column stands for a distinct word. So we use this column means function to calculate the average frequency for each word, and then we sort them in descending order. And then we only select the top 20 to display. So you can see here like film, movie, one, lakh are some words have the highest frequency. Well, if I then use a mean function, we can calculate the average frequency for all these top 20 words. So basically, it is calculate the average, the mean for these 20 numbers. So it is more than 1.7. So each word appears averagely at least twice. Almost twice, sorry. And next, we will show the frequency for this 20 words in a bar plot. So you can see, well, film and movie are two words that has the highest frequency. Sorry, here. Well, next, if we only want to like compare the average frequency, and if the zeros are not counted in averaging. So for example here, before we calculate, for example, for word 1, we like sum 2073205 and divided by the number of reviews, which is 7. Well, now we want to eliminate those zeros, so we only want add up those non-zero values and divide it by 1, 2, 3, 4, 5. So this is how we want in this function. Well, firstly, we first transform them into a matrix, and then we convert zeros to NA, which are missing values. And then we can directly use this column means function again, but remove those NAs, remove those missing value, and then sort them in descending order. And display only the 20 top frequency words. You can see that if we exclude all the zeros, we can have like a higher frequency calculation, and the average frequency of these 20 words are more than almost 2.5. And then we can also bar plot those 20 frequent words. Well, like we did before, but using the tm_map function, we construct our own stop word list, including some specific words such as movie, film, review, 1, 2, so on and so forth. So here we like do this step again without the tm map. So we include the 1, 2, 3, get movie, film, and films. Those words doesn't make any contributions to positive or negative sentiment analysis. So we compose this my stop word list. Oh, here, sorry, we still use this tm map function to remove these words from our training corpus. So after removing those training corpus, we can do this again, the document term matrix, removing stop words to lower stemming and so on and so forth. So remember before we have about, that matrix has about 22, more than 22,000 columns, which means now we should have less. Well, it'll eliminate almost 100 words. And then we can also remove those sparse terms. So before we have 200 frequent words. Now we only have 195 with frequent words. So like 5 words such as this film, movie are limited. So after we removing our specified, our personalized stopping words, let's see the top 20 most frequent words again. Let's see, only the 20. So now we no longer have movie, film, so on and so forth. The most frequent word is lack. The second one is character. And the average for most average frequency for these 20 words is 1.194. Well, you can also like plot it using this bar plot function. Next, we're gonna use this word clock function to generate 30 words. Well, this word clock function is a function used to visualize it for visualization. It can generate some really pretty word clock based on the frequency. Depending on frequency of the words, it will adjust the size of the word and the color of the words. So here, the first parameter is for it is the word itself. This one is the frequency, the size, the color. So here is an example of this word clock. It's really pretty. You could paste it in your paper or project. Now let's start to build sentiment classification models. The first thing is to create the training data frame for training the models. Well, this string remove spar_m is from the document term matrix with 200 frequent terms and their frequency in it. And we first convert this document term matrix to a metric using as metric and name it as train backup word frequency matrix. Well, the rows for these metrics are the reviews, and also the columns are still the terms, the frequent terms. And then we use data frame function to combine the label. Remember, we have the sentiment label for each review for training data set. So we combine this training, the review labels from training data set with our backup word frequency matrix and create a data frame. This data frame is used to train out all our models. And well, this label will add one more column. So basically, if we see the structure of this data training data frame, we can know that in total we have 201 variables. Well, the 1000 observation stands for the 1000 reviews, and the one variable is the factor variable, the sentiment, positive or negative, as our predictor. And the rest 200 variables are those frequent terms we generated before. And the values for this values for each predictor are the frequencies. And well, we also save the backup words generated from the training dataset for later usage. And the length of this backup words should be 200. 200. Well, next we want to create our testing data frame. We will start with testing data 1. The first thing is to transform the review content to a corpus, and we name it as testing1 corpus M. Well, next with this corpus, you can do the pre-processing step by step, but we also can use this document term matrix and include all the pre-processing parameter here, like to lower, remove numbers, punctuation, stop words, white space, stemming. Well, you notice here we add an additional parameter called dictionary. Well, this string backup word M is the backup word we saved from our training data set. So with this dictionary, this document term matrix only calculate the frequency of the words from this dictionary. So basically, if there are any other words in this testing data 1, this function will ignore them. They only compute the frequencies from these 200 frequent terms from training 1. Even though those 200 terms may not be frequent in testing 1, they still only calculate those 200 words to be consistent with training data set. So let's run this one, and well, you can know the dimension. Well, in testing data 1, we have 500 reviews. So now we add 200 frequent words. So this matrix should have 500 rows and 200 columns. Like these 200 columns are same. The words are the same as the training data frame. Well, the next, similarly, we will transform the format from document term matrix to matrix. Then combine the testing data set, the reviews from testing data set, and combine the label with the 200 words frequency matrix and compose them as a data frame. And this testing 1 data M is the testing data frame we're gonna use for evaluate the models. Well, as you can see, similarly, we still got 201 variables. One is for the factor predictor, negative, positive, and the rest 200 are the predictors, terms. Well, next we're gonna here we listed all the classification models from our last class, our data mining class, the decision tree, neural network, Bayesian, support vector machine, and the k-nearest neighbor. Well, we will only demonstrate you the C-tree, the neural support vector machine, and Bayes models. Well, you can try the rest of them offline if you like. So we first will try the C-tree classifier. The first thing is you need to load the package library called party, and we use this C-tree function to build a decision tree model. The data we're gonna use is the training data M, the data frame, training data frame we just created, and the Y is the sentiment label, positive or negative, for the reviews from training data set, and dot represent the rest 200 terms, the frequent terms we obtained from the training data set. So this model is called BOW C-tree M, and Well, next we can plot this model. So let's zoom in. So let's first look at the leaf. The leaf are blocks. Well, you can see the black block, the black part of the block represents the positive sentiment, and the white block part represents the negative sentiment. So, for example, this one, because the black block is larger than the white block, so for the reviews that fall into this leaf will be predicted as positive because the black block is larger. So let's look at one simple path. So for this review, if this review included the word bad more than once, and the great, if they also include the word great more than 3 times, this review will be positive, will be predicted as positive. Well, next we will use the testing data 1, the data frame, to evaluate the prediction results. The first thing is to generate a prediction for the testing data frame, for the reviews from testing data frame. So the first parameter, if you still recall, the first parameter is a model, and the second one is the testing data frame. Well, next we will evaluate the prediction results using confusion matrix and also M matrix. Well, M matrix is from R minor. So if you want to use M matrix to combine like accuracy, recall, precision, F measure, those evaluation matrices together, you should first load this R minor library. And this is the label, the sentiment label, for the actual sentiment label for each review. This is our prediction. So let's see the evaluation result. So you can see like the accuracy actually is not very bad. It's good. It's over 63%. And well, next we will try the naive-Bayes model using E1071 library. Well, similarly, we first built a new naive-Bayes model using the string data frame with label as predictor and the rest 200 terms as it was labeled as target variable and the 200 terms as predictors. And let's check the evaluation result. Well, naive-Bayes model performs better than the C-tree model. And the third one we're going to demonstrate is a kernel support vector machine classifier from CurLab. And similarly, we build a model and evaluate them using testing data 1. Well, among these 3 models, kernel support vector machine performs the best. The accuracy is over 75%, and in terms of F measures, both of the sentiment classes, for both of the sentiment classes, they're like above 70% as well. Next, we're gonna demonstrate you the performance on testing data frame 2. Well, similarly, the first step is still like convert the review contents to the corpus and do the pre-processing, calculate the term frequency altogether using document term matrix. Well, notice here we still use dictionary equals to backup word from the training dataset in order to keep the features, the variables, consistent. So the variables from both training and testing 1, testing 2 are the same. Well, as we can imagine, the dimension for this document term matrix for testing data 2 is 500 and 200. Well, next, we will convert the document term matrix to a matrix and create a data frame by combining the review labels from testing data 2. Well, in the end, we will still demonstrate you with those 3 classification models, and you can also try them later offline. The first one is still C-tree model, and the 9-base model, and lastly, our support vector machine kernel model. Well, you can see like for testing data 1, C-tree performs 9-base performs better than C-tree, but for testing data 2, in terms of accuracy, still like 9-base model performs better than C-tree model, and the support vector machine outperform the other 2. So the results are also consistent with our performance in testing data 1. So this is what we cover for our sentiment analysis, sentiment prediction for movie review using only the backup words as predictors. So if you have any questions, please let us know in class. Thank you.